composite glass fibers as introduced in the 1942. The glass fibers are during 1942. The glass fibers are introduced by reinforced composites were first used in structural aerospace parts. In the early 1960s, high-strength glass fibers S-glass were first used in joint work between Owens Cumming Textile Products and Untitled States of Air Force later in 1968. The glass begins evolving into a variety of commercial applications. High-strength glass fibers combine high strength, high stability, transparency, and resilience at a very reasonable cost to weight performance. The utilities of high-strength glass fiber composites are accompanied by physical, mechanical, electrical, thermal, optical, radiation properties. What is meant by glass fiber? The glass fiber composite strength weight ratios are higher than those of most other materials, and their impact resistance is phenomenal. Further, they possess good electrical properties, resistance to moisture and outdoor weathering, and resistance to heat chemicals. These properties are coupled with case of fabrications. Composites are artificially produced multi-phase materials having a desirable combinations of the best properties of the constituent phases, or more precisely, their material consists of fibers of high strength and modulus embedded in a bonded to a matrix which distincts interfaces between them. Classification of composites are three types: particles, fibers, and structures. In particles, there are divided into two: particles, large particles, and dispersions and strengthened. In fibers, continuous and discontinuous. Continuous is aligned, discontinuous short. In discontinuous, there are two types of composites: aligned and randomly obtained, structured, laminated, and sandwich. Properties of glass fibers: incombustibility, corrosion resistance, high strength at low densities, good thermal, sound insulation, special electrical properties. Manufacturing of glass fibers. Glass fibers are basically made by mixing silica sand, limestone, boric acid, and other minor ingredients. The mixture is heated until it melts at about 12,600 degrees, letting the molten glass flow through fine holes. The glass strands are cooled, gathered, and wound. The fibers are drawn to increase and directional strength. The fibers are woven into various forms for use in composites. Types of glass fibers: soda lime glass, electrical type, chemical resistance type, alkali resistance type, and high performance applications. Various properties of different glass fibers. Properties: tensile strength, E-glasses 3.5 GPa, modulus. Different characteristics of glasses E, S, and AR glasses, and tensile strength, modulus, elongation, density, reactive index, coefficient of thermal expansions, dielectric constant. Radius have three types of E-glass, air glass suspensions. Properties are there. Forms of glass fiber reinforcement. These form: a glass fiber is particularly suitable for high strength, low weight laminates. Continuous filament glass is preferred in these applications on account of its greater strength and low bulk factor. The fabric woven from continuous filament yarn ranges in thickness from 0.00 to 2.02 inches. In general, direction properties of laminates depends on the type of weave and cloth setting employed. The example of the fabric reinforced plastic is aircraft radar. In this application, a material is required which will allow the radar rays to go without distortion from the rays, sending equipments out the target and then back to radar receiving equipment on the plane. It must also stand the air pressure, strain, or sonic or sulfonic speed. Combination of glass fabric and low pressure certain provides an excellent answer to these requirements. Modeling techniques methods are almost ligand and spray saturation and mixing, continuous impregnation, laminating, cure or flat or corrugated panels, solid rods, hollow bar stock, compression transfer and injection molding, filament wrapping and winding, centrifugal and static casting, potential modeling, cold forming, combination of these above. Application of glass fiber composite. Glass fiber composites are making roads many markets due to general properties of excellent molded surface, finished almost all size, lightness of weight, insulation against heat transfer, aircraft airspace, appliance and equipments, constructions, consumer goods, corrosion resistance, electrical rods, tubes and components, land transportation, miscellaneous, tools, material handlings. Glass fibers are used in both radial and bias ply automotive tire reinforcement. The Owens Corning Corporation introduced glass as a tire cord in a composite impregnated with 15 to 30 percentage reciprocal formaldehyde latex resin which protected the individual glass filaments. The glass fibers was first used as belt in belted bias tires with a neoclown across. It enables the crown regions of the tire to be reinforced, which is turn increased in the tread life by about 1 to 5 times compared to the conventional bias tire. Commented as conventional bias play and steel reinforced belt bias tires, the glass reinforced tire provides a softener ride. Conclusion means this I want to conclude that glass fiber composites really taking away the market from conventional materials like metals with further new technological advancement in glass fibers and resins. Their composites always have been able to satisfy the need of any engineering field. At least I want to say that the GF solutions for growing building engineering avenues, the Corning Corporation introducing glass tire cords of composite impregnated, coated and protective individual glass filaments, which is compared to the conventional bias play steel reinforcement belt bias and the glass reinforced type provide a softer ride. Because of this protective individual glass filaments, the first used in the belt is nylon across and the GFU solutions growing building engineering avenues. At last, I want to satisfy that. Thank you.